Hi everyone. It's been a few months of work, but today is finally the day. I'm launching my first frame, the AOS5. In this video, I'm going to take you through the design of the frame step by step. We're going to look at some black box logs of its performance. And if you want to get involved, there are links down in the video description to where you can buy this frame. So let's get into it. Okay, so now let's look at the design of the AOS5. Now the first thing you'll notice about this frame is that the arms are quite unusual. Rather than having a single strut that comes out to the motor, they actually have two struts. One that goes to the center of the frame and one that goes to either the front or the rear standoff. And the reason why I've chosen a truss structure for this frame, well actually there are several reasons. The first is that in a frontal loading situation, rather than that frontal load being converted into a bending moment on the single strut of a normal frame design, a frontal load creates tension in this member of this strut here, creates tension in this strut here, and compression in this strut here, and actually avoids putting too much bending moment on either strut. And this allows us to make the struts quite a bit thinner without sacrificing any strength. Another reason for the strut design is that you end up with this very wide base where the struts meet the body of the frame. And this provides enormous torsional stiffness. So as I try and turn this motor mount, I mean, there's absolutely no way that I can rotate that. And that's really important because a lot of the vibrational modes that trouble typical frame designs involve torsion of the motors left and right. Or forward and backward actually, and that's simply not a problem with this frame design because of that absolutely enormous torsional stiffness that's afforded by the truss structure. If we think about bending now, bending is another important aspect of arm design because a lot of difficult vibrational modes involve the motor moving up and down and the arm bending up and down. And for the AOS5, you can see here, I've actually gone for a 6mm thick arm. So I've been able to do that because this truss structure actually saves a little bit of weight. So I've been able to use that to make the arm even thicker. So it's a 6mm thick arm. And that provides tremendous stiffness in bending and strength in bending as well. And that helps reduce the effect of those vibrational modes on the gyro by pushing the frequencies a lot higher. Obviously, with this kind of complicated arm design, you would expect that the arm might be a little difficult to change. I'm very happy to say that changing the arm on the AOS5 is still just two screws. So this screw here, and then the arm just comes straight out. You can replace it, two screws to secure the new arm in place. So it's still just as easy to take the arm off of the AOS5 as it is for almost any other frame. If we come now, so this camera plate is designed for the DJI FPV camera. So it's a 20mm wide camera mounting. It will also, of course, fit any micro camera with a 1mm washer. The camera plate on this frame does quite a bit more than just protect the camera. It actually interlocks with the front arm down here to provide a bit of additional stiffness and a bit of additional strength at the root of this front arm, which is going to be important for durability of the frame. It also has this strut coming along the top of the top plate here, and this is designed to reinforce the top plate in this area. So there's a full depth cut out and then another half depth cut out here. And by locking into the top plate, it provides a lot of additional longitudinal and torsional stiffness of the top plate in specifically this location. So if we look at the top plate now, you can see why that extra stiffness from the camera plate is really needed, because there's a 32mm by 32mm GoPro mounting pattern here. So it's for a 3D printed GoPro mount, so you would screw the GoPro mount down using these holes, reuse the screws for the front two standoffs, and add two more back here. And then the camera plate provides additional stiffness in the front section so that the weight of that GoPro moving around doesn't cause any flexure of the top plate, or doesn't cause too much flexure of the top plate. You can also see that there are some triangular cutouts in the top plate. These have been specifically designed to try and maintain the maximum amount of longitudinal and torsional stiffness of the top plate, so that and the reason why I want to maintain the torsional stiffness here is because these stiffness in these directions, longitudinally and torsionally, are the most important for the performance of the frame based on the analyses that I've done. If we look now at the standoffs, you can see that we've got 15mm standoffs all the way along. I think the ones that CNCMadness are going to provide with the frame are going to be black, but if you want to get your own custom coloured standoffs, like I've got some gold ones here, just standard M3 15mm standoffs will be perfect. They're all 15mm. We've got some sandwich plates as well. There's a sandwich plate at the back of the frame here, one in the middle, and also some little spacers up front. And this is all to keep the standoff height the same across the frame, but also to provide additional stiffness of the arm in bending, in that vertical bending mode. So this one here, you know, like that. If we come now and look at the bottom plate, you can see that on this frame design, we've got 30.5 by 30.5mm stack mount in the front, another stack mount in the front, so this one's 20 by 20. And then in the rear of the frame, we've got a 30 by 30 and a 20 by 20. So there's quite a lot of room for you to build this out how you want to. If I show you one that I've built up earlier. So here's a frame that I built up earlier. It's got a 4-in-1 ESC and a flight controller in the front, and these are 30 by 30, both of these. And then it's got a full-size DJI unit in the back, but of course you could have something like a Calyx Vista if you wanted to instead, or an analog VTX, of course. You can see I've mounted the antennas of the air unit actually out onto the front strut of the rear arms. And the reason that I've done that is that I've had issues in the past where long antenna mounts have actually acted like mass on a spring and actually vibrated in flight. And so by strapping the antennas very securely to these struts and keeping the length of unsupported antenna, you know, as short as possible, you avoid any risk of the antennas creating vibration. This frame supports up to 5.1-inch props, and they are a tight fit at 5.1. But it's designed for 5-inch props, and it's really designed for action cameras like the Hero Session, not so much the Hero 8 and Hero 9, because they're getting quite a bit heavier. I would say that for a Hero 8 and Hero 9, I'm going to do a 5.5-inch version of this frame specifically for carrying those heavier action cams. I want to take a moment now to talk about my philosophy behind the manufacturing of this frame. Now, I'm working with a company called CNCMadness to manufacture this frame, and they're based in Canada. They do great work, but critically, they cut every single frame to order. So when you order, they cut the frame from stock material. And what this means is that they will always cut the frame to the latest designs. So as I learn more about how this frame performs, and as I get feedback from people like you who maybe test the frame out, I'm hoping that I'm going to be able to improve the design, make it perform even better. And as I do that, I'm going to be updating the designs with them. So whenever you choose to order, you're always going to be getting the latest and the greatest design. You're never going to be getting old stock or a previous design that's not as good as it can possibly be. And I think that's really important. That's going to be something that I want to carry on with all the frames that I design in the future. Whenever you order, you should always be getting the very latest and greatest design with all of the feedback, all of the learning, all of the knowledge that we build together as a community in FPV baked in right from the very start. If you would like to try the frame out as it is now, then there's links in the video description. You can go to CNCMadness, you can order the frame, they will cut it for you to the latest designs and ship it out. For those of you who want to see a black box log analysis and the results of a resonance simulation of the AOS5, I'm going to be doing those as part of my perfect AOS5 build, where I build an AOS5 out complete with all the components that I would choose to give the best possible flight feel. If you don't want to miss that, make sure you're subscribed. That's going to be coming along very, very soon. Thanks for watching. If you decide to buy an AOS5 and try it out for yourself, please let me know how it performs for you. Reach out to me on Discord, leave a comment on this video, email me, feedback how it works and how it could be made even better. And I'm going to take all of that feedback and keep evolving the design so that people who order, a week, a month, a year from now are going to get just the best possible frame that they can. I really appreciate all of your help, all your feedback and all your support. Until the next time, happy flying.